Hello, you're most welcome to today's lesson. As I earlier indicated, today's lesson is called circle theorem, that is plane geometry 2. Circle theorem simply means angles in a circle. Angles in a circle. With this topic, we are going to deal with about 8 theorems. So we'll take our time one by one and go through all the theorems so that the understanding and everything that you need will come clear. Before we zoom in, what are the theorems, or what is a mathematical theorem? If someone asks. A theorem is a statement that can be demonstrated to be true by accepted mathematical operations and arguments. That is the definition for theorem. It's a statement that can be demonstrated to be true by accepted mathematical operations and arguments. So with this one, we are going to deal with 8 theorems. Now, let's zoom into the theorems. Let's know what the theorems are. What does the first theorem say? According to what I have here, the theorem says that the angle a chord makes at the center of a circle is twice the angle it makes at the circumference of the same circle. That is, the angle a chord or an arc makes at the center of a circle is twice the angle it makes at the circumference of that circle. What does this one mean? Just look at the diagram below. You could see that according to the theory, it says the angle a chord. So can we identify our chords here? First one, we have this one. We have this one because a chord is any line drawn from one part of the circle to touch the other part of the circle. That is the circumference. So, but with this one, this is the chord I want. So I can draw my chord just perfectly as it has been illustrated. So this is my chord, and the angle this chord subtends at the center is twice the angle it makes at the circumference of this circle. In a short, the angle here and this one, because it is coming from the same chord, twice this is equal. That is, twice this angle will give me this angle. This is the center of the circle. So the angle this chord makes at the center of the circle is twice the angle it makes at the circumference of the same circle. Now, let's look at the demonstration. Welcome. This is the demonstration for the first theorem. What does the theorem say? It says the angle a chord subtends at the center is twice the angle it subtends at the circumference. The upper say semi chord be the same. Once you say a chord be a line drawn from one part of the circle to touch the other part of the circle. The semi chord say na chord no it make angle at the center. Chord no make angle at the center. Na sa chord na sa it make angle at the circumference. Once a chord now I make angle at the center, and then once I make an angle at the circumference. Or say so what per angles necessary na I'm you and the tisa habako. Twice this is equal to this. Chord. This is my chord. And one I make angle also. And then once I make angle at the center. It was a me perhaps the end there, and I may perhaps I you and the mammy habako. So in case this is 10, this one will be 20. In case this is 50, this one will be what? 100. In case this is 120, this one will be what? 60. because also twice this is equal to that. That is the first theorem. So you can extend it to any part of the angle. If it might be BBC, it doesn't mean say m cos rho and no, it's the same thing. With my side bar, and I'll have the same angle because nina I was circumference so. It's not translate to sometimes bit me BBC. Can you say how you and a mommy? Aha. But what I say, very simple. Twice this, you can just move on to have different shapes. Aha, and a mommy have twice this will give me that. So the angle a chord makes at the center of a circle is twice the angle it makes at the circumference of the circle. Now, we have seen a demonstration that the angle of a center of a circle is twice the angle of the circumference. That is the first theorem. Now we are going to prove it. I hope you know that we can prove it. The reason why we are saying the angle at the center of a circle is twice the angle of the circumference. We are going to prove it. All what you're supposed to do is follow the step one by one, and at the end I'm sure you can prove it yourself. First thing you're supposed to do is to draw a circle of any reasonable size, as I have drawn mine here. Second step is to draw your course. So I have drawn two courses indicating my center. I have this one as my center, and these ones are my course. Remember, I can draw another chord here, but for the sake of explanation, I will leave that one for now. Now, the next thing I'm supposed to do is indicate my points. So I have to indicate it using letter A, B, and C as my points. The next thing is to indicate my angles using the arc. So I have done that exactly. Now I'm supposed to draw a line from B through O, that is the center, to touch the circumference of the circle, that is the arc AC, and I have drawn that. Now the next thing we're supposed to do, because we want to prove it, we're supposed to know that we have two triangles in the circle. I have this triangle OAB, and again I have triangle OBC. These are two triangles that is going to help us to solve our problem or to prove it. Now we know that in triangle AOB, line OA is equal to line OB. Line OA is equal to line OB. Why am I saying so? Because they are all radii. Line OA is a radius and line OB is a radius. That is why we are saying these two lines are the same. So line OA is equal to line OB, and I have indicated it here as they are all, which means angle OAB is equal to angle OBA. Angle OAB is equal to angle OBA. That is, this angle is equal to this angle. Angle OAB, this angle, is equal to angle OBA, this small angle, and we can name that angle as our X, which means this and that are the same. The reason why we are saying they are the same is that this one is a radius and this one too is a radius, so they form a triangle, making the triangle to be an isosceles triangle. So isosceles triangle is having two of its angles being equal. So angle X and this are the same. Remember, What we have done here is the same thing we are going to do for this triangle OBC. Now check. In this triangle, we know that OB is equal to OC, taking triangle BOC. Just like what we did, this line is equal to this line. Now we know triangle BOC, OC is equal to OB because they are also radius. So triangle OBC is equal to OCB. That is angle OBC is equal to angle OCB. This angle is equal to this angle because triangle BOC is an isosceles triangle. So this angle and this angle are the same. Now we need to indicate that angle using letters. So I can use letter Y to represent that angle as I did earlier on using X. Now we are not going to find the reason why twice of this angle, that is X plus Y, is going to give us the whole of this angle AOC. Now note this: the external angle in a triangle is equal to the sum of the opposite interior angles. What this property means is that taking triangle ABD, these are interior angles. X and X are interior angles, and where the cursor is the external angle. So if I want to know the external angle here, I need to add the two interior angles together, and whatever result I will get is for this external angle. So in case I want to find this angle, that is angle AOD, all what I supposed to know is add the two interior angles, the opposite one, and the result will be here. Which means if I should add X plus X, I'm going to have 2X here. The same thing applies to this one. If I should add X, Y plus Y, I'm going to have this answer here. That is what this property means. So AOB is equal to 2X, and then angle COD is equal to 2Y, which means this angle is 2Y, this angle is 2X. So in case I want to find the total of this angle, I want to find the total of this angle, what should I do? I need to sum these ones up. 2X plus 2Y, and that is it, 2X plus 2Y. In summary, I'll just factor 2 out here because 2 is very common here, and I'll factor 2 out here, even X plus Y. Now remember, the top one here is X and Y. So in case I want to know the total angle here, I need to sum X and Y up. So X plus Y, and that is what is showing here. So according to the theorem, it says twice this, which means I should multiply whatever I will get here by 2, and that is the 2 waiting for you here. So twice this is equal to that, and that is exactly what we have proved. For we know that angle ABC is X plus Y, which means angle AOC is 2 times angle ABC, and twice this one is equal to this, and that is exactly what we have done here. So twice this is equal to that. Thank you. Now let's work out some examples under this theorem. Example 1. The question says we should find the value of X if O is the center in the figure below, and that is exactly the figure we are talking about. So find the value of X. The solution is very simple. We know where S is located, and we know twice this is going to give us that. So in case I have this one, all what you're supposed to do is multiply the top one by 2, and that is exactly what we have here. So S is equal to 2 times angle ABC, and ABC is 60. So 2 times 60 is 120. Very easy question. Second example, the same thing. Find the value of x if O is the center. Now there have been some changes. X is up here and y is there is a figure 216 down here. So how can we solve it? I know twice this one will give me this. So if I have this, I just have to divide it into 2 and I'm going to have this, and that is exactly what we have here. Thank you. Now try these questions on your own. After that, you can send me the result. Thank you very much for watching. This is Circle Small, your 21st century teacher. See you in my next episode. Bye bye.